Good afternoon, everyone, and welcome to the Construct Innovate webinar series on modern methods of construction. My name is Jamie Goggins, and I'm co-director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology and Innovation. So this is a webinar series on modern methods of construction that runs over an 8-week period. We're on week 3 now, so the spotlight this week is on timber. So it's on modern methods of building smarter and greener homes. So as per our typical layout for these webinars, we've got 3 speakers. Again, we're so fortunate with the speakers, the caliber of speakers that we have again today. So we've got 3 speakers. Our first speaker is going to be Dr. Patrick McGetrick, who's director of the Timber Engineering Research Group at the University of Galway and in Construct Innovate, and he'll give you an overview of timber construction in Ireland in terms of the current landscape and recent research and development. Then we have Brett Chrystal, who's head of sustainability or sustainable design at DRES, so a developer of residential buildings in particular, and he's going to talk about modern methods of construction and design for manufacturing and assembly from the developer's perspective. And then we're going to get it from, I suppose, a manufacturer's or supplier's perspective, where Campbell, who's managing director of Glenfort Timber Engineering, and he's going to go through some case studies to showcase mass timber construction in modern methods of construction. So we're going to have our 3 presentations. So our 3 speakers will each present for about 15 minutes each, and then we'll deal with questions and answers at the very end. So as the speakers are presenting, if you have any questions that you want to pose to our speakers, please do put them into the Q&A function at the bottom of your screen there. You'll see it on the bottom of your screen. And as I said, we'll deal with all the questions at the very end. So without further ado, I'm going to hand over to our first speaker, Dr. Patrick McGetrick, Director of the Timber Engineering Research Group based out of the University of Galway. So over to you, Patrick.
Thank you very much, Jamie, for your introduction, and good afternoon to everyone. I'm delighted to speak here today about timber and construction in Ireland. And I have a slightly shorter title on the slide here, but I'm covering an overview of timber and construction in Ireland, including some recent research and development. I'm associate professor here in civil engineering at the University of Galway, and as Jamie mentioned, I'm director of the Timber Engineering Research Group here. We've listed a number of our projects at the bottom of the screen. We're quite busy. So I want to give you a brief introduction to what we do here, so you have the context for some of my presentation. So the research group here was established in 2004 by Professor Annette Hart, and we cover a range of different research areas that relate to timber engineering, ranging from assessing timber properties, whether that's assessing standing trees in a forest, to testing structural products in a laboratory setting, all the way through to life cycle assessment, numerical modeling, instrumenting structures, and carrying out testing of existing buildings. To give you an idea of the kind of funding we receive to carry out the work we do, over the last 4 years, we've received over about 3 million euros across. At the moment, we're currently running about 14 different projects at national and international level that relate to timber engineering. And there's a picture here of a visit from the Department of Agriculture, Food and the Marine and the Minister in 2023 to our labs here. So why are we talking about timber today? And I'm sure a lot of the audience are quite familiar with timber, but some may not be as familiar. Timber in general is the name used to refer to wood that has been converted into structural or non-structural products. And one of the reasons our research is focused on timber is, well, one of the main reasons we focus so much on Irish timber is that it's a local homegrown resource. It's a renewable natural resource. And in terms of primary structural materials, it has the lowest carbon footprint and energy requirement for manufacturing. So that gives you an advantage in terms of energy use, but also where, and I'll talk a little bit about it later, where carbon emissions become more significant in terms of reductions from construction. It's a material that can help us a lot in that area. It is reusable, recyclable and biodegradable. And I guess contrary to some perceptions about timber, it is highly durable when properly designed and detailed. And of course, in many cases in Ireland, we treat our timber that's used in timber frame construction. just as an example, the oldest timber building in the world based in Nara in Japan is over 4,000 years old. So timber structures can be designed and maintained to last a very, very long time. And of course, for timber more recently, and following the theme of the series, there are a lot of associated MMC innovations or modern methods of construction systems that are using timber for those reasons. And the general eco cycle from the forest through the logging, producing products, all the way through reuse, whether that's through wood waste, use as biomass for heat and energy recovery, or back to the start again to grow new trees. The full cycle is shown here. The question has been posed, can timber-framed homes using Irish timber be part of the solution to reduce carbon emissions? And that does underline a lot of the incentive and the motivation to make greater use of timber. And there's an important line here from this article that was in the Irish Times about a year and a half ago, that 80% of Irish timber is exported to other countries, where much of it is used in timber frame buildings and construction. And we would like to see a lot of that timber where it's feasible to be used in construction in Ireland, and that motivates part of our research work here in terms of showing that it is suitable. I did want to show a summary of different types of products that are used in construction in Ireland for those that mightn't be aware of all of the different options. But starting from the top left, maybe the most common, sawn timber used in our timber frame houses, in joists. Most common areas we're used to seeing it in roof trusses. But then there are engineered wood products or mass timber products, where we're taking boards similar to those used in timber frame construction, but effectively creating much larger elements from them by layering the boards and gluing them or fastening them together in some other way, and to create mass timber elements that can be used to span much larger distances to create floors, walls, and roofs. And we'll see some examples later on from both Brett and Cathal about different applications of these systems. And of course, glued laminated timber, which can be used for beams and roof construction. And anyone who shops in their local Lidl, I'm sure, will have noticed the newer buildings are all using very large glulam beams in their roof structures. So it is becoming a more common sight in Ireland. Other types of elements that can be used as well that mightn't be as common in Ireland yet, but are also engineered wood products or mass timber products, are laminated veneer lumber, like LVL. Examples shown here. This is very much like very large plywood, because the veneers that are used in these elements are typically around 3 millimeters thick, but sections you make from those can span 40 or 50 meters or more. So these are being used in very large structures. Parallel strand lumber is similar to the forms, just that it is formed from strands or fibers that have been chipped or formed from other logs or materials, and you can use waste materials from plywood and other LVL production to make these, and they're bonded together in a press using adhesive and the strands to form long sections. And again, long span beams and columns use this type of system or material. Composite systems are also used, so like metal web joists, which are quite common in timber frame construction in Ireland. That's an example using Irish timber. And floor cassettes use these types of systems as well, and in many cases will use Irish timber. And there are other products like panel products such as oriented strand board, plywood, and MDF that are used in different construction applications like flooring and wall sheathing and facades. So that's a number of products and systems that are used and can be used in construction. So why timber, and what are the challenges and opportunities in Ireland? One of the main drivers for modern methods of construction and harnessing the benefits of the efficiency you get from that relates to changing populations and housing demand. So the latest figures that were proposed in program for government, whereas 60,000 new homes required per annum, eventually reaching that figure, and up until the last few years, that figure was around between 30 and 40,000, and it's been gradually increasing. And I'll show briefly why there's why we need to increase that. Our completion rate, by the way, has gone down in the last year, and that's something that we have to consider. I've made a point here about, in Ireland, we've the lowest population living in apartments. But should we be building taller and be making greater use of the space that we have in our urban areas or cities? For example, vertical extensions on buildings, which definitely make use of modern methods of construction, such as modular systems, they may require lighter weight structures where the existing building has been designed to a limit of a foundation, for example. But timber can provide a solution there, because it tends to be a lighter system than other types. This just shows general population growth, but I wanted to highlight for Ireland the population projections that have been published by the CSO it's a few years ago now, but of the range of projections where you have the upper range and lower range, where we are currently, we're right at the upper end of the projection. So our population is certainly increasing at the upper end, where housing demand is not going to decrease anytime soon, I would say. Something to note for Ireland as well, in terms of the kinds of developments and or the types of housing that is predominant here, and is very understandable from a cultural and tradition point of view, is that nearly 90% of people will live in houses in Ireland. So that's Ireland at the top there. These are the EU countries. You can see the blue is the EU average. And if we look at apartments, just for comparison, Ireland has the lowest percentage of people who live in apartments. And that has significance when you have increasing populations in our cities. So maybe something to consider. So I've already mentioned harnessing these methods for benefits of speed on site, quality control, prefabrication, the ability to use local materials and supply chains, and reducing on-site labor. And I have examples here at the bottom of the screen from Sweden, where they're building 6- and 7-story modular timber apartments regularly using their homegrown resources. Some other challenges relate to greenhouse gas emissions. A lot of our emissions come from the built environment, and timber can help reduce that. And if we are building more and we have to build 60,000 houses, we will have an associated increase in the carbon footprint if we continue with only traditional construction materials. And you can see already that timber frame is being used to a greater extent in housing in Ireland. There are opportunities that relate to our forestry. Our output of roundwood that can support our construction timber is almost doubling by 2035 to 8 million meters cubed per year. And there's an opportunity there, particularly with the likes of mass timber or engineered wood products, to use more timber for taller structures, or at least substitute where it is suitable and feasible to do so, substitute for concrete and steel to gain the benefit of emissions and carbon storage within the material itself. Just one note from the right-hand side, because I've covered some of this already. In Scotland, up to 92% of new dwellings are constructed using timber, and we're at about 24% here. There's some other challenges that I've listed here. I might move on. I'll leave the slide up fully just to highlight within life cycle assessment, where we are assessing the environmental impact or the carbon emissions produced from the production of the material. Timber products will tend to have 8 times less emissions than concrete by volume. That doesn't necessarily mean the building will be 8 times less, because the volumes used of each material will be different, but typically you would expect to use less material and gain savings there. I wanted to cover some policy drivers which support greater use of timber in construction. So the revised Energy Performance of Buildings Directive, the EPPD, which will require calculation of whole life cycle carbon for new buildings and achieving fully decarbonised building stock. And that will definitely support greater use of timber, or require it if we're to meet emissions targets. The updated construction products regulation, which came into force this month but will be applied fully from January next year, will require mandatory declaration of environmental data and life cycle impacts of construction products, an expanded DOPCs, or declaration of performance. So that for timber, that will probably have, where limits come in under the climate action plan or under procurement rules, that will have an impact on the use of timber. Okay. And there are other drivers that relate to green public procurement as well, in terms of how we procure our public buildings. And that will require reporting of carbon emissions from construction where timber can support it. I did want to highlight the activities of the Timber and Construction Steering Group, which is an interdepartmental group established at a national level with the aim to create the conditions to increase the use of timber in construction, to examine regulatory and standardization challenges in relation to design guidance and fire, safety and fire, and aspects like that are of concern, and greater use of mass timber systems. There are 5 thematic groups. There have been 2 recent publications shown here on the right, and there's more information you can find on that online. I have some images showing other examples of cities that are adopting wood as their primary construction material, just to show the range of developments, including the tallest, one of the tallest timber buildings in Europe that's constructed from modular mass timber, and it's a hotel, 20 stories, and the tallest building at the moment that uses timber is 25 stories in the US. So it's not limited to 2 to 3 stories in terms of its structural ability. 1 or 2 slides on research projects, but I may just direct you to our website in the interest of time. There's some images here of some of the mass timber products that we've been manufacturing and testing. And I'll move ahead to our website. Sorry. Oh, before I move to the website, I should highlight, maybe importantly, our Construct Innovate research projects with DRES, which Brett will talk about. We have another project with UCD and G-frame structures. And I wanted to mention our projects with Quelcha, which will be looking at the first Irish homegrown timber housing estate in Ireland. And Quelcha have also developed the Timber Spec, a training program that provides additional training for timber if you're interested in learning more and developing more CPD. Final remarks summarize what I've already said. So I'll just leave up the slide with more information from our website, where you can find a lot more information. And thank you very much for your time.
Move on to our second speaker. Second speaker is Brett Chrystal, who's Head of Sustainable Design at DRES, and he's going to talk about modern West construction and design for manufacturing and assembly from their perspective, which is from a developer's perspective. So over to you, Brett.
Just a bit of background. I'm Head of Sustainable Design at DRES, been here for 3 years. I'm an architect by training. Just want to highlight a couple of items. Just DRES as a company, been around for about roughly 50 years. The Durkan name is kind of synonymous with building an island and has been through quite a couple of iterations over the years. We are now called DRES Construction, as in Durkan Residential Construction, but not to be confused with Durkan Residential, so it's shortened to DRES. We are mainly a household builder, doing housing, duplexes, and occasionally apartments as well. Just in terms of our footprint, we're basically producing 95% timber frame. So going back to Patrick's figure, this is all new build. The 5% that's missing from there is the ICF that we use in some of our houses, or have used in the past, and also in the duplexes, where the bottom floor is typically mortar, blockwork on the bottom floor, and then timber frame above. As you can see, fairly large numbers coming out last year, 460 units, and anticipated 320 units going forward this year. Our MMC journey, I think just to give you a bit of background, Patrick alluded to some of it. But I think the items from a government perspective which highlight the most is the NESC report, which came out at the end of September last year, which refers to the MMC and the greater adoption of MMC for residential development in order to meet the housing targets. They brought out that council report. There's also a governmental report, Modern Methods of Construction, an introductory guide for those who are not familiar with it. And then there's also the interdepartmental steering group, which Patrick referred to early on as well. Which he is part of, and I'm part of one of the subgroups. So just with regards to that, so let me just get this out the way here. These are the two groups that we're actually involved in. Patrick mentioned the TG1, the Timber Group 1 was the Market Opportunity Group, which we're involved in, and that's just been with a tender has gone out to Arup. We are doing a research project with them, and then the Timber Group 3, which is public procurement and demonstration projects, with the Timber Construction Group. And these are the two documents that are likely to come out. I think the TG3 one comes out in March, April, and the Arup one comes out in June. Just a bit of background on the same sort of thing, framework in terms of the EPBD, which came out in May, the CPR, which Patrick referred to, Climate Action Plan, just in terms of what they're trying to achieve, 30% reduction in greenhouse gases, the National Circular Economy Program, and then the RIAI Climate Challenge, which basically targets 450 kilograms of CO2 equivalent per square meter for houses by 2030. These seem like very difficult targets to meet, but they're actually not, we found, just from going through a carbon analysis of our own buildings. Just to start the DRES journey, as I mentioned early on, we had started with insulated concrete forms in some of our buildings due to speed and the site and the technology available at the time. We've moved away from that just from an environmental perspective, speed perspective, and basically moved on to timber frame construction, typically with an external brickwork cladding on the outside. The graph at the bottom will give you a good idea of the just a comparison between where we were. If you look at the ICF, this is a whole life cycle template that we found, basically giving a factor down at the end here for the total A to C parts of the whole life cycle analysis and where we're sitting at the moment in terms of it, the differences between them. And it's quite clear that it's from an environmental perspective, using timber is definitely the way forward. I think a lot of people tend to think of modular construction, MMC, typically being volumetric, which is the first, there's actually 7 stages of volumetric. People tend to think of volumetric as being the whole house. They typically see this being produced off-site, brought on vans and brought into site. That is potentially the ultimate aim, but I think the majority of modular in Ireland at the moment, and I see going forward, would be structural panelized modular, which is 2D modular, so effectively off-site pre-manufactured components in a factory, and that pretty much makes up the entire envelope of the building. So from hybrid walls, joists, roof cassettes, and even floor cassettes going forward. From the LCA performance I was talking about early on, we're talking about the RIAI targets. The target on the top left corner where you see the 336 kilograms CO2 equivalent, that is one of our buildings if we used blockwork. And this one at the bottom over here is the one that we currently have, which is timber frame with blockwork on the outside. And you can see we comfortably, even using blockwork construction, just using timber trusses, building environmentally friendly, we can easily achieve the figures of 450 kilograms equivalent. Our journey from timber frame into mass timber basically was a logical journey for us, just in terms of our timber. We're moving more and more into 4-story walk-ups, apartments, duplexes, that sort of thing. And we felt that given our history in innovation, we were one of the first, or we produced one of the largest passive house developments in 2017 in Ireland. And we've had other sustainability prizes over the years. And this was the next innovation for us was basically using engineered wood to produce buildings. We chose to do this at Newtown Mount Kennedy, one of our developments, 480 houses. We're producing a creche of 600 square meters and a community center of 400 square meters. This just gives you an aerial view of that. They're 2-story buildings, so sitting within the current building regulations. The superstructure is CLT, and that includes the floors, the walls, and the roof. We're using glulam columns, beams, and rafters. The substructure is concrete, so effectively from the ground floor slab upwards is all mass timber. Just for those that weren't fully aware of the mass timber versus timber frame. Timber frame is obviously just a sort of stick system. As Patrick alluded to early on, the two main ones are the CLT, the cross-laminated timber, which you see being panelized at the bottom here. And the other is the glulam beams, which is the ones you're seeing in the central picture here. And in the top right, you see a combination of that. Glulam columns and then CLT floor plates. Motivation for using the mass engineered timber, sustainability, obviously, in terms of the only one which sequesters carbon between concrete, steel, and timber. The lowest global warming potential, just giving you a carbon footprint equivalent, very rough in terms of aluminium, steel, reinforced concrete, and wood in terms of a ton of CO2 emitted. Operational effectiveness is the lower heating consumption, air tightness, indoor air quality, and then obviously the construction part of it as well, which is what we're going to head into now, is the DFMA process, which is the design for manufacture and assembly. Leads to speed, faster programs, and greater speed of erection. Partnering with us on this has been Construct Innovate and the University of Galway, who've provided us with seed funding. The two seed funds are for the mass timber demonstration building project, where we're going to be using the creche and the community center to demonstrate the use of typical CLT floor, wall, and roof cassettes, standard connections, standard tapes and membranes across these typologies. And then the second part of the seed funding is basically a living lab to assess the post-occupancy satisfaction of the users, air quality, and basically user friendliness of the actual structures themselves from a well-being perspective. Part of that analysis, which is being done by two students at the University of Galway, is 3D volumetric modeling, analysis of the envelope, isolation of CLT components for DFMA manufacture, building energy modeling, thermal modeling, and whole life cycle carbon assessments. Our aspiration on this is to move towards zero carbon net zero, and that is typically achieved by using basically the whole envelope as green as possible, from wood fiber insulation to the structure being timber, to the products all being certified. Even the steel is recycled steel. So that is the target, and this is sort of typical section of the buildings. The DFMA process, we approached Agadomus, which is an Italian timber structural engineer who I worked with previously in South Africa. They've done over 300 mass timber structures, and they were instrumental in guiding us through the process in terms of panelization, connections, fixing typologies. On the top right, you can see sort of the idea of this, like a Meccano set or jigsaw puzzle to be put together, where each piece is fabricated, numbered, and basically when they put it onto the trucks, it gets put in, last in is first out kind of principles. And every single component of this is analyzed, from the services that provide penetrations through it, all the way through to stair connections, roof and wall connections, etc. They've done a full engineered structural analysis of this, including wind loading, all the fixing types, vertical loadings, stresses on the connections. They've gone through all the modular components and how these fit together and how they typically could be supported. Just to give you an idea of the structural analysis that goes into it, this report is 233 pages long. It analyzes every single nut, bolt, plate connection that is on the building. It's not generic, it's specific to every connection. Just to give you some idea of typical details that we've been designing with them, the idea behind this is that the inner structural grid is fully timber. So you've effectively got glulam beams and columns. You've got your CLT, which runs over the top. Even the roof is a CLT panel. And that allows us to create a single envelope and creates an ease of erection. It also enables us to put the insulation as a continuous membrane around the outside of the building. All of our tapes are continuous, all of our membranes are continuous, and as a result, we can get air tightness probably close to passive house kind of levels. As you can see on the bottom right-hand corner, you'll see there the subframe of the building, the substructure is in concrete, but from the ground floor upwards, you would typically see the glulam columns coming up, and there you can see the CLT with wall connections, and then we've got the wood fiber insulation on the outside of that. This is just a view on the top right corner of what we're imagining the community center would look like inside. Parts of it will be encapsulated, but parts of it will be exposed as well. The learning curve for us has been obviously moving from timber frame into CLT is not a huge difference, but there are certainly differences in the tapes and the connections. Top left corner, you'll see typical details of concrete to the CLT wall connections with adjustable feet, typical screw connections, tapes through thresholds, tapes where you have penetrations, membranes between components, membranes around windows and doors. The biggest issue for us from a developer's perspective is obviously mitigating the risks. And obviously the biggest of those is surprisingly not fire, it's actually moisture. Moisture management principles is something that we've looked at in depth, and there's actually a moisture management report that goes out literally tracking the CLT when it comes from Sweden, where we're getting ours from, directly from there all the way to us with moisture management the entire way. And there's actually a book called the Mass Timber Insurance Playbook in the UK, which we've used as the basis for that for our insurers. Fire protection principles, there are pretty standard methods of working it out outside there for glulam beams, as well as the charring rate of wood, which is calculable. You can see it's 0.65 millimeters per minute in terms of the char rate, and effectively that is just added onto the size of the remaining structural element that you require so that you can build up either a 30-minute or 60-minute fire rating. In the areas where we're exposing the timber, we need to prevent the surface spread of flame. So there's actually two different parts. One is the fire component itself, which is actually how the timber burns, and the other part is the surface spread of flame. So to prevent the flame spreading, we are using a product called NT-Deco, which will be painting onto these walls after they've been erected to prevent that surface spread of flame. The other side of it is just how we erect these things is completely different in terms of using different kinds of propping mechanisms, the MEWP mechanisms, and then craneage. We would typically be using craneage for roof trusses, but generally not speaking for walls. In this case, the walls, the floors, everything's going to be craned in parts and put together like that jigsaw puzzle. This is a finished CGI of what we imagine it's going to look like. On the right-hand side, you've got the creche with the playground in front of it. On the left, you've got the community center. And then that's just another view from the bottom, just showing up that's the creche on the left-hand side and the community center on the right-hand side. And that's pretty much it. Thank you very much.
Brilliant. Thanks, Brett. And great to see the details and also the use of that mass timber in it, and that you can even leave several elements exposed in there and still meet the regulations in terms of fire and durability and so on. So I'm sure a lot of hours of time and effort have gone in thinking about all the details going through in that. So fantastic. So anyone has any questions for Brett, please do put it in the Q&A there at the bottom of the screen. So I'm going to move over to Cathal now, Cathal Campbell, who has a lot of experience of delivering buildings for many years in timber construction, and Glenfort Timber Engineering themselves being at the forefront of innovation within timber construction. So over to you, Cathal, for your presentation. Thanks.
So I'm going to go into sort of more of a case study today based on projects that we've worked on previously. It's more about projects we've worked on, but before we do that, I'm going to sort of give you a background information on our company, Glenfort Timber Engineering, to give you a bit of insight into the case studies before we go to them. So we're based up in County Tyrone. We're a third generation company, essentially. My grandfather started a construction company many years back, and he went into a very specialist restoration work, where they found themselves doing a lot of larger beam structures, little mass timber at that stage, more solid beam structures. Glenfort Traditional Products was named at the time. I've only known myself working around the yard and working in the timber industry, and when I came out of university, I was very fortunate to spend some time in America and Australia in companies who work with mass timber. So brought a lot of experience back. to Ireland here to continue the growth of the main business, and we sort of chopped the name up and changed to Timber Engineering. So we are sort of, as it says here, unrivaled in the quality of our work, and hopefully are continued leaders and innovators within timber industry in the UK and Ireland. We set our company up with 4 main pillars. Full solution mass timber company. So what is full solution? We try to be able to bring a project from humble beginnings at design stage right through to on-site fitting. So the main points are design, engineering, manufacture, and on-site fitting, all here within our own headquarters. Design, good design is the heart of any project. We've spent a lot of time here developing our design team, and not only the team and the personnel who are the backbone of the business, but also bringing in specific software. We're the only company in Ireland using specific engineering and design software for timber engineering. What we do is we create 3D visualization, 2Ds, generation drawings for most projects that come to fruition, even at actually tender stages and even at stages with private clients. We'll put together a lot of visualization and drawing packages. This small project you're seeing here in the middle is actually in Roscommon Town. It's not one of the case studies, but the whole project was done on a BIM model of our own that was then fed to the concrete companies, the copper companies, and everyone on board, 2 or 3 different subcontractors to the main contractor, including ourselves, was working off the one BIM model through our timber engineering software, and it went together absolutely exceptionally on site. So it's a great reference for using the up-to-date software that's available to us. 1 second, it froze up again. Apologies, guys. Hold on. Here we go. Sorry about that. Don't know what's happening. Okay, timber engineering. So we have 2 full-time timber engineers. A bit like Brett was talking about the company in Italy, we do the very same here in Ireland. This all started about 9 years ago now, where we teamed up with the 2 schools in France, ENSTIB, which is on the east coast of France, and ESB, they're in Nantes. It's a French engineering. They're both engineering schools based on biosource materials and mostly timber. We bring in final interns for 3 months every year, and interns in the first or second year during the masters for a couple of 2 to 6 weeks at a time. This has been amazing for us. Our 2 engineers, one comes from each school, Simon and Alex, full-time. They are structural engineers by trade, and then they go on to their masters in timber engineering. That gives us a real niche within the market. We're able to take a project from the very beginning and do all the engineering on the project that's required for the structure and all the elements that we provide, whether it be the CLT, the glue lam. We do all the connections, the steel work, we give the point loads to the concrete. And it's a real sort of feather in our cap that we've started doing and really helped our business along tenfold. Is unbelievable. We've also invested in a new manufacturing plant up here in Tyrone, fully mass timber building itself. We run German machinery, Hundiger and Rex. This links directly with our engineering and our design, where our Campbell, our software, what you see is what you get in the 3D element, the 3D drawings, go straight to our machine, working off very small tolerances. And very quick video here. These videos are excellent with nice music that they're planned to be with, but you'll have to listen to me instead. This is the newest machine, newest edition, new CNC that we waited nearly 2 years on. German, it's a robot drive 6-axis CNC. It's the only one in the UK and Ireland that's operational. We're very proud of this. It's been a big investment to us. We can machine timbers from 1250 to 300, quite large members in mass timber, or as you see in the video here, some solid oak that's gone through it. So it's very versatile, very compact compared to our older machines. All right. And then last sort of pillar of the company is our on-site fitting team. We've got a great experienced crew. I mean, wealth of experience over the years, and bringing in new project managers in the last 12 months, safety officers, site engineers. The guys have worked on a world of different projects between the UK and Ireland, especially more so even the last 5 to 6 years, and continue to keep them training and up to date. And they're always on the road. They could be in any corner of the country on projects as they are at the moment. Just going to touch on mass timber in general. I'm conscious to overlap what the guys have already spoke about today, so I'll run through this part quite quickly. Mass timber in Ireland industry is growing, an emerging sector, as we know, due to sustainability trends, more eco-friendly building materials. Growing market, as I said, mass timber and glulam are our main timbers. We do solid member timbers as well, still massive timbers, so to speak. Alternatives to your standard concrete and steel within the construction sector. Of course, a lot of projects are hybrid, where they will have their concrete foundations, some steel connections and whatnot. But in terms of embodied carbon, using your timber in general will bring that down. Ireland, like many EU countries, is forced to reduce its carbon footprint. Mass timber is considered a more sustainable option as it captures carbon dioxide during the growth of trees and continues to store the carbon dioxide material. It's estimated that about a ton of CO2 is stored within every cubic meter of timber. That varies between different timber species, of course. We do the calculation base for this. It's been asked for more and more all the time now for mostly commercial projects, where we give them our waste management and our embodied carbon and our timber. But it's important to realise it's not just a set of calculations. It needs to be based upon what would have been there, whether it be concrete, steel, or something else. You need to have a comparison of these embodied carbon calculations. So this brings you on nicely to our case studies, our portfolio of works. I've taken a project from each sector, being domestic, commercial, restoration, and domestic work, and energy, as we call it. Their projects have been done within the last 12 to 18 months. So we'll start off here. This is a domestic project, which is a full CLT building. Full carcass, walls and roof all in CLT. This was a domestic project done down in South Dublin. Again, I have a nice video here I'll share very quickly with you. The manufacturer, we bring the panels in and we do the machining of them, but we do all the sizing, the engineering in-house, the design, and again the connections. This is a 2-story building, quite a large domestic build, as you see. It's got 140 mil wide CLT walls and 220 thick CLT decks. It's a flat roof. This is part of our crew going up. We stitched the connections, as you see here, so there'll be a half lap connection stitched. There's shear walls in this site, which was a benefit for ourselves, getting the client to choose CLT. We were able to go in with our lorries loaded up in a method statement where the first panel off was the first panel up on site. We were on site a total of 14 days, 2 days setup, getting the foundations ready and an AluStart connection system that we use, and another 12 days standing all the panels and the walls and the decks. So comparison to a traditional build, it's absolutely amazing in terms of time frame. You'll notice there a blue coating on all the CLT. That's a protective membrane. There's many on the market. This one is at Euro 3000. It's a protective membrane that seals the CLT but lets it breathe at the same time. It's self-adhesive. We put on here in the factory. It goes to site, and then all the joints around the windows, doors, and everything are taped. Essentially, you could really get passive standard with this using it. The external of the build is wood fiber, 2 layers of 100 mil wood fiber. They have a small cavity and a very decorative tile finish on it. Internally, this is a non-visual CLT build. What I mean by that is the walls are being counterbattened, which is it's very easy to run your services, and then plasterboard. The client didn't want to see it as a timber build, although they do have now a few feature walls within the building itself. But a lot of these buildings in mass timber now are non-visual. You see a lot of the Scandinavian type CLT homes or buildings that you see online. They photograph them because they are visual. But there's a lot of non-visual out there, which seems to be the way a lot of people are going. Commercial project. This one's very close to ourselves up in Tyrone here. It's actually a friend, a friend of ours, a wedding venue. This is where I got married myself at quite a while back, but it's not. It didn't look like this. Marquee at the time, they were changing into a solid building as such in this way. The building is an oak frame building, and the external with a glulam building on the internal. Again, a quick video, and not keep this too long. The building itself, we done the engineering, the design actually, and we done the on-site fitting. The project was brought to us very conceptual. There wasn't even an architect involved, to be quite honest. So we done 3 different designs. Thankfully, the client liked one, and we based our drawing set on that. You see the 3D drawings we spoke about earlier in the presentation. They are directly linked to our CNC. What you see, what you finish with, what you sign off is what goes to site. So the interior designer opted for glue laminate inside rather than painting the oak, which is a good cost saving. The building itself, we stood the structure and then we enveloped it in a closed timber frame system. The walls and the roof cassettes were done in this way. They actually started cutting ground on the week before Christmas, and the first wedding was held in this venue on the 31st of March. So the diggers were going out the back door and the bride was going in the front door. It was a very impressive turnaround for such a scale of building. We done all the external cladding system as well, and the roof cladding, and the glazing was done by others, by a local company. Restoration brings us to a third case study. We chose the Drogheda Civic offices. You've probably seen it on our social media in the last week or so, those of you that follow us. This project, like most restoration projects, grow legs as they go along. We started out with the project with the replacement of a couple of trusses, but when we started to go and do some analysis on site, we realized that this main building, all 5 trusses needed replaced, as well as a cupola, which had a copper top on it at the finish. So there was a lot of traditional work went into the more restoration side of the business. This is where the business started, and it's still a focal point of the business. We have great craftsmen in our workshop that we've been trained over the years, and in actual fact, we didn't put any of this through the CNC. The restoration architect was very adamant of that, so all of this was hand done in French oak. So it was a beautiful project, and it's really livened up that end of the town in Drogheda. For the energy sector, I'd say it's new to us over the last 3 years. I've chosen 2 projects for this. One is the energy sector, is the Maxall EV hubs. The reason I've chosen this one in particular for today is modern methods of construction, I suppose, being the title of everything. We've a contract with Maxall to roll these out in 4, 5, 6, and 9 bay EV cantilever charging systems. But if you look at the project on the left, was the very first one we done up at Kinnagar outside George Best Airport in Belfast. It was brought to us as a project for pricing up, and if you can see here, it's actually a steel structure that's cladded, and it still looks great, and the lighting system's in it. But we went to the architects in the middle of this actually, and we asked them, could we redesign it? And they gave us a bit of rope to let ourselves go and do that. We spent a bit of time modularizing these frames. So whether it's 3 up to 9 bay EV charger, we've modularized them. So everything's machined in-house. We've stainless steel bracketry, but we've a rotational moment connection in the ground. What that's left is the main contractors on site get the groundworks ready. We give them loadings. We can go in and put up a full frame, including a CLT roof or lattice roof, whatever's chosen, polycarbonate finish within Monday to Friday. So we've modularized that whole thing. We're back here on the original design. It was taking almost 3 weeks because you're dealing with other trades. We like to do that, value engineer projects, and it means we can uniform them for machining. So the next one was in order, you've quick sign off and you're ready to go. And energy number 2, I've chosen to show the Circle K. Anyone that's traveling on the East Coast will probably see this in your eye line and down the M1 between Louth and Armagh. This project was a private client who is part of the Circle K group. They had a tricky situation getting planning, and when they brought it to a sustainable planning, they got their planning through. It honestly came to us with a quick sketch on a page that looked like trees. So we got a free rein to design what we needed. We went with an external Douglas fir, CLT roof, and we had to tie it back into the existing building. But it turned out very well. I'm just going to flick on because I'm very conscious of time here and probably running on a little bit further than I should. Irish glulam. So all glulam, or most glulam, is imported European lumber. So your lamellas make up your glulam beams, and they're machined. Glulam usually starts at a GL24 strength grade. Ireland's forestry is primarily made up of non-native species such as Sika spruce. So there is a potential to use Irish timber in the Irish market, especially, and possibly further afield to export this as well. Notable projects is Avondale. I'm just going to jump onto that quite quickly, conscious of time, as I say. So a project we done with Quilcha a few years back is the first ever and only still project ever done in 100% grown Irish timber, procured from Quilcha Forestry because it was Quilcha's new headquarters and 3 buildings. We procured the timber, which is C16 Sika spruce, graded it and dried it and produced glulam beams. Now, the 3 buildings themselves the design was quite simple, but engineering wise, the standard GL24 glulam, you lift a data sheet or a connection sheet of anything, it all starts at that. So what we had to do is go back to the drawing board, because our Irish glulam made of C16 strength Irish lamella was making that GL20 glulam grade, which is still pretty impressive. But what happened was we had to go back and do a lot of hand calculations for all 3 buildings. The scale of the beams had to be upgraded for the lower strength grade. Not by much, believe it or not. The 140 thickness we were able to keep and bring the heights up on them. But it turned out very well. We've actually got a 26-meter beam that was difficult to get up through the Wicklow Mountains in the cafe area. But it's a great visitors park if you're ever down that way, anyone. Most recently, we're doing some testing with Queen's University, and this is actually hot off the press, pardon the pun. These pictures came to me yesterday. We have a student there, Emily McMaster, and they're doing some load burst deflection. These are Irish glulams, 13 meters. We manufactured 5 of them for the university, and we're delighted that we're partnering with them to do this testing on our glulam beams. So that sort of wraps up Glenfort and what we do and the projects we're working on in Ireland. We're looking forward to a few projects coming up in the new year, or this year, should I say. We have a modular mass timber that we've developed with the prototype sitting in our workshop. We're doing fire testing now with a few partners in February. We have a guest accommodation hotel block, all being well, coming up. And my own personal favourite is this free-form car garage, which is going to be done in the glulam oak. And this is a live project called the O House by Lawrence and Long Architects. It's ongoing at the minute. So thank you very much for your time. I hope you enjoyed that, and I didn't keep you too long. Thank you.
Brilliant, Cathal. That's fantastic. Absolutely, lots of beautiful buildings there, beautiful workmanship on show, which is the buildings themselves. It's a pleasure to be in a lot of those buildings. So that comes to the end of, I suppose, our 3 presentations.